Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework section 9.4. Now, 9.4 is taking a look at the conic section, the ellipse, and the ellipse is a circular shape that is elongated in one direction, elongated either horizontally or vertically, and we'll get into that a little bit more. Let's start off with question number one. They're kind of going through some of the definitions of the ellipse, and I think, like I said in the last section, we looked at the focus point on parabolas, but the foci are not necessarily a necessary part of 120 anymore. So I'm going to let the foci, the equation for foci points on the ellipse go. And but we talk about it just a little bit, and then I don't have you actually find the focus point. So let's go ahead and get into this. It says fill in the blank. A blank is the collection of points in a plane such that the sum of the distances from two fixed points called the blank is consistent. So an ellipse is a collection of points in a plane such that the sum of the distances from two fixed points, these two fixed points, by the way, are going to be focus 1 and focus 2, two fixed points called the foci. That's just plural focus, right? So what they're saying here is, and it's kind of a cool thing, when you've got this ellipse, the ellipse is actually defined by, you've got focus 1 and focus 2, and every single, so the sum of these two pieces, let me just draw a line from here to here. So if you add those two lengths, the sum of those two lengths will be the same. And if you think about this being a piece of string, right, it's not going to change, then the sum of those two lengths would be the same, right? And so you go something like that. You know, you can even take this one right here, that one right there. But anyhow, each one of those pieces, and if it's drawn perfectly, the sum of those two lengths will be exactly the same. And in that case, you would have something called an ellipse. One of the cool things about the ellipse is that, and this is a little bit too confusing on how many I drew, but one of the cool things about the ellipse is that, like, for instance, they say in the Oval Office, if you find the foci points, you can actually whisper, and the sound waves from your mouth are going to perfectly bounce against that curvature and go to the other focus point, and vice versa. This is focus 2. So you could have two people on these focus points or foci points that they can talk to each other at a level that really no one else could hear very well. But since all these sound waves are focused to the other focus point, you could have conversations. Kind of a cool idea. All right, let's move on to the next one. For an ellipse, the line containing the focus or foci is called the major axis. So that's just saying, you know, you've got a minor axis, which is is the shorter distance, and then you've got this elongated major axis. So this would be the major. And they're saying for an ellipse, the line containing the focus or foci is called the major axis. Yes, the focus or the foci, focus number 1 and focus number 2, are going to be on that major axis, not on the minor. It's always going to be on the major elongated axes. And by the way, these ellipses or elliptical curve, this can also be elongated vertically. And so your foci, you'd have one here and one here. And just like before, it still would be sitting along the major axes vertically. It's that stretched out direction. Number 3, the 2 points of intersection of the ellipse and the major axes are the vertices. Yeah, that's true. Okay, let's take a look at that. So if we weren't looking at the focus or the foci, and you're just looking at that major axis, it's actually going to hit the ellipse at these 2 points called vertex 1 and vertex 2, or vertices, plural. Okay, so now, and I'm not going to really ask those questions on the test. I'm really just going to have you graph them and do some of those kind of things. So let's take a look at the kind of or not the application, but the ways of graphing it, or looking at the graph and figure out what the graph looks like, or vice versa, looking at the graph and coming up with an equation. Which equation shown below is the graph of the is the equation of the graph? Okay, so what I'd like to do right now is try to tie some things together, because you already looked at circles. So let's go back to circles for 1 second. Right? If you did the previous rather section, or 2 previous sections ago, 9.2 I believe instead of 9.4, you would have the circle. And the circle, the basic circle centered at the origin, just look like this: x squared plus y squared equals, and it might have been something like 3 squared. So we know the center of the circle is at 0, 0, and the radius is 3. Now, that's the standard form for a circle, and it's that way for a reason, because you have one radius. But in the ellipse world, in the ellipse world, our standard form is just a little bit different. And I'm going to try to explain why. Now, if we were trying to apply the ellipse idea, standard form for ellipse on a circle, what we would do is we'd come along here and we divide by this constant on the left and the right side of the equation, and we would end up having the ellipse world likes to put the radius down below. Whoops, that's a square. And set it equal to 1. And what that does is it breaks out the radius in the x direction, right? It breaks out the radius in the x direction, so you go 3 to the right, 3 to the left. And it also breaks out the radius in the y direction, 3 up and 3 down. But since the radius on a circle is the same, it's kind of pointless to do it that way. So with a circle, we just like to have our standard form of x squared plus y squared equals 3 squared, and then our radius is just right there. Okay, so an ellipse, you can't just have one radius because it's elongated in one direction. So we want to break those radiuses down. It's not a radius anymore. It's called a major or minor axis now, okay? So here's how we would do this one. So now this particular ellipse that I'm looking at, this graphed, is definitely centered at 0, 0. So you're just going to have x squared plus y squared. Now we like to, in the ellipse world, we like to have it equal to 1, like this form right here. That's our standard form. Now we want to figure out the radius in the x direction. It's not a radius, okay, but I'm just kind of using that language from a circle. So how is this elongated? How is this graph elongated in the x direction? Well, if it was kind of like a radius, it would be this guy right here. So 2, 4, 6, 8, 10. So this distance is 10. So associated with our x, which is our horizontal, under the x would be 10 squared, kind of like we have with our radius with the circle r squared. And what is associated with y? Well, y is our vertical up and down, and you can see the y has a length of 8. So under the y squared would be 8 squared. And so this is what it would look like. And what particular equation goes with that? X to the 100th plus y to the 8 squared, which is 64. This is C, so the answer is C. Okay, and our major axis is going to go with this red 10, right? And so it's just whichever one's elongated more is the major, right? 8 is smaller than 10, so 8 is the minor. Not super important. Let's see if we could do this one. Well, the first thing I'm going to look is, yeah, it's centered at 0, 0. Okay, so it's centered at 0, 0. That's the center. So that means that this is going to have to be x squared plus y squared. And we do know ellipses, we like to have them equal to 1. And then we go ahead and take a look at in the x direction, which is horizontal. How long is that from the center out to the ellipse? That's 4. So below it's going to be 4 squared. It is vertically stretched a bit, right? It's a little longer vertically, and that looks like it goes to 7. So y, right, is associated with vertical, so below y is going to be 7 squared. And that equation right there would graph this particular graph. In fact, we could check it. Maybe we'll check it, but let's first identify which one is this. It should be x squared over 16 plus y squared over 49. X squared over 16, it's going to be D. Okay, whoops, for some reason this thing is just freaking out on me. There we go. Okay, so, we can check this. We can actually grab a point and check it. Why don't we do that? Just to satisfy ourselves here. Let's see, that point is 4, 0. So I'm going to go ahead and run a check on this. I don't have a lot of space. Let me do it over here. Check point 4, 0. That should work with this equation that I made. So it's going to be x squared over 4 squared, which is 16, plus y squared over, 7 squared, which is 49, and that's supposed to equal 1. So let's go ahead and check it. Well, if I'm going to use 4, use 4 for x, and I'm going to use 0 for y. 4 squared is 16, so this is 16 over 16, plus 0 over 49, which is 0. 16 over 16 is 1. 1 equals 1. Yeah, that point does work, and it is a point on my ellipse. Okay, let's do another one. Now, in this one is the opposite direction. Instead of giving us a graph and trying to come up with the equation, they're giving us an equation and trying to isolate or identify the proper graph. So you can see the previous problems, there weren't any shifts. Well, now we have a horizontal and vertical shift going on. And you can identify the horizontal shift by looking at what's associated with the x, and the vertical shift is what's associated with the y. And they are in parentheses, so it's going to be the opposite of what we're looking at, just kind of like when we did with parabolas. What is the center going to be? Well, the center is going to be, I see x minus 5, so the center is 5. I see y plus 5, so the y value is negative 5. There is my center. That's the first thing I'm going to do, because some of these graphs are not even possible because they're not centered right. So 5, 0, I'm just going to start here because this looks like it might work, and I hate how they marked this graph. Geez, what is this? 3, 1, 2, 3, 4, 5. They're counting by threes, and I got to go 5, and they're counting by threes. This is lame. Anyways, I go right about 5, and then I go down about 5. So I think that's about there. So that approximately looks pretty good. This one actually looks like this could be about right 5, because that's 3. Oh, it'd be about there. 2 more. Wait a minute. This is 3, and that's 6. Okay, I'm sorry. It'd be slightly to the right is what it should be. Should be slightly to the right. So that looks like the correct center, right? 5, negative 5. These don't, no way. And they're in the wrong quadrant. So those two are okay. Now, how do I identify which one it actually is? Well, what I would do is I then would take a look at its x. Let's write this in our proper form, 3 squared. Okay. And when we look at my y value here, what's the axis of the y? Well, this is going to be 5, whoops, the color change, 5 squared. So what I need here is, in fact, you can even now say that this ellipse is going to be taller than it is wide, because look at the y component is 5 and the x component is 3. It's going to be taller than it is wide. So it looks like A to me. It looks like it goes to the right 3 and to the left 3, and it also goes up 5 and then down 5 to get our points. And so A is going to be the correct solution. You know it's not B for sure, because B is elongated horizontally. That value under the x would have to be bigger than the value under the y, and it's not. All right, let's move on. Let's see, hopefully this is making some sense here. Okay, the very first thing is I want to find the center. So I look at this and I find the center. And the center is, so I take a look at the x component. So x minus 2, so the x value is positive 2. And y minus 5, so the y value is positive 5. So 2 comma 5 is my center. 2 comma 5. Okay, so is this, I mean, we want to know, is this even possible? So I think A is possible. Let's see. I need to zoom in. 1, 2, up 5. Well, at least this is marked individual lines, individual intervals, so it's easier to see. And then this is also 1, 2, up 5. This is also 2 comma 5. Those are both 2 comma 5s. This one's 5 comma 2, so that's not going to work. And this one's 5 comma 2, so that's not going to work. Okay, so it's either A or C. And we can tell which way it's elongated also by just taking a look at the value under the x, and I'm going to write it as a perfect square, 5 squared. And the value under the y is a perfect square, 4 squared. Okay, so that means this is going to be wider than it is tall, right? Under the x is a 5, so I must go to the right 5 and also to the left 5. And then under the y value is 4 squared, so I must go up 4, 1, 2, 3, 4, and then down 4, 1, 2, 3, 4. And then that gives me my points, my vertices this way, and it gives me my points that I could then graph my ellipse. So this must be C. Okay, and moving right along, number 8. Well, number 8 has, what's under there? It's not 0, it's 1, and I could write that as a perfect square, can't I? I could write that as 1 squared, and before I used red, so I'm going to use red, 1 squared. And under the y value, I could write that as 6 squared. Now my center is going to be, so x minus 1, so the x value is 1, y plus 4, so the y value is negative 4. It's always opposite. Oops, that was too much. Okay, so let me find a 1 comma negative 4. And once again, what is the scale on this thing? 1, 2, 3, and then a tiny little one. Yeah, this is awesome. Anyhow, so 1 comma negative 4. Well, this is in the wrong quadrant for right 1 and down 4. That's not going to be it. Right 1, down 4. Well, that might be it. Let's see, right 1, down 4. That has a chance. Right 1, down 4. That has a chance. No way. That doesn't have a chance. Then the next thing is, well, which way is it elongated? Well, I've got under the x, I've got that red 1. So it's only going to go to the right 1 and left 1. And then under the y value is 6 squared, so it must go up 6 and down 6. It's going to have to be C. C is going to have to be the graph. And it is. And let's take a look at 9. Okay, 9 is not in the standard form that we want it to be in, so all we have to do is zoom in and divide both sides. We have to make this equation equal to 1. That's our goal, because that puts it in standard form. So we divide by 36 to make a 1 on the right. Divide each term by 36. Okay, now let's just go and see what do we get when we do that. Well, you're going to get x plus 1 squared, and we're going to see that 4 goes into 4 once, and 4 goes into 36 9 times. So we're left with this 9 right here. I'm going to say plus, and we can also see 9 goes into 9 once, and 9 goes into 36 4 times. So this is a 4. And up top was just right here. That's just quantity y minus 2 squared. Okay, that is in our standard form for the ellipse, and we go ahead and identify under the x is a 3 squared, and under the y is a 2 squared. And we can identify our center real quick. The center is going to be negative 1 comma 2. So negative 1, so that's in the wrong direction. So negative 1 up 1, 2, that looks good for a center. Negative 1 up 2, that is not going to work there. center -1 up 2, -1 up 2. Okay, there's another possibility. Now let's see. Well, it says it's going to elongate in the x direction. It's going to be wider than it is tall because of that 3 is bigger than 2. So when I look over here, well, wait a minute, this is not even ellipse, right? This particular problem says it goes, I can't even read that. What's the 1, 2, 3, 4, 5. So 1, 2, 1, 2, 3. Okay, yeah, it's just the graph is not, the little boxes are wider than they are tall, so that is horrible. That's actually an ellipse, but it looks like a circle. Jeez. Okay, anyhow, the problem with this one is my information is saying that I'm supposed to go 3 to the right. 1, 2, 3 to the right. 1, 2, 3 to the left. And then under the y value you can see is that green 2, and you go 2 up and you go 2 down. So yeah, this is definitely not right. Over here, we have 3 to the right. 1, 2, 3. 1, 2, 3 to the left. Yeah, that's working. And it says I go up 2 and I go down 2. Yeah, it's clearly going to be D. I wish those. You see when you make a graph and you make your boxes rectangular, it stretches the graph out in the more than it should be in a certain way, and it makes things that are elliptical look circular. That's horrible. I don't know why they did that. Okay, down to 2 more problems and we're done here. Well, that looks like a mess, number 10. I meant to actually stretch that out so I had space to work, and I didn't do it, darn it. So what I'm going to have to do is I'm going to have to copy this down. I'm going to zoom out a little bit. I've got to copy this particular problem right down here, just to get some space to work. Yeah, that should work. Okay, so what I need to do is remember what does an ellipse look like? Well, when it's in its proper form, if I zoom in right there, it has a perfect square with the x's. It has a perfect square with the y's. You hear that again? Perfect squares, right? You have 2 perfect squares. We've got to complete the square. That mess has to be completed. And we must have a perfect square. So I'm going to write, I'm going to start gathering some stuff. This is going to be number 10, and it's going to be 25x squared. And so I've got 25x squared. I'm going to collect my x's, plus 50x. I'm going to put a parenthesis around that just to highlight that stuff. And then plus, let's collect our y values. That was what, 36y squared. That is going to be right here. And negative 432y. And then this guy, I'm just going to move this over and get it out of there and put it on the other side. So I'm going to subtract 421 on both sides. So these guys are kind of grouped. And then on the right hand side, I've got negative 421. Okay, now I could kind of zoom in and look at this a little better. Okay, so now remember when we complete the square, what has to happen? Well, we have to have this leading coefficient must be 1. So I've got to factor out that 25. I mean, it's really gonna cause some problems coming up here, but I've got to do it. Factor out 25, that gives me x squared plus 2, and 2x rather. I'm going to leave a space to complete the square. Same thing here. This leading coefficient must be 1 to do my completing of the square. So I factor out 36. That leaves me with a y squared minus, and then 432 divided by 36 is minus 12y. And then I'm going to leave a space to complete that square. And on the right, we've got negative 421. And of course, I'm going to have to add whatever I add on the left, I have to add on the right. Now, we're going to have to be really, really careful. And the reason why we have to be careful is because whatever I put in here actually, at the end of the day, gets multiplied by 25. So we got to be really careful. And whatever I put in here, if I put a 1 in there, it's not really a 1. At the end of the day, it gets multiplied because 36 is going to distribute to it. It gets multiplied by 36. You got to be extra careful with this problem. So first of all, let's go ahead and figure out what do we do to complete this square. We take that 2, we cut it in half is 1. We square 1 and we get 1. So 1 completes the square. But be very careful because that's not a 1. At some point in time, that 25 is going to be multiplied by a 1. By putting a 1 inside parentheses with 25 hanging out there, you just added 25 on the left. So now we have to add 25 on the right. Let's write what this thing factors down to. We completed the square, so this should be a perfect square, and it is. It's 25 times x plus 1 quantity squared. Well, that looks a whole lot better. Now let's do this one right here. I'm going to take negative 12. I'm going to cut it in half, negative 6. I'm going to square it, 36. So that means I'm going to add 36. Now if you add 36, if you put 36 in parentheses with a times 36 along with it, that's not 36. That's 36 times 36. That ends up being 1,296 you just added to the left. So that's what I have to add to the right, 1,296. Yeah, this is a little bit complicated. Okay, so now we've got plus that 36 on the outside. And we just completed the square, so we know that this is going to factor down to y minus 6 perfect square. And on the right-hand side, when I sum all that up, I get 900. Remember, the standard form for ellipse is that we must have this equal to 1, so we divide by 900 to turn that into a 1. We divide each term by 900 on the left. Well, some nice reducing is going to happen. In fact, 25 goes into 25 once, and 25 goes into 936 times. And 36 goes into 36 once, and 36 goes into 925 times. So let's see what we have. We've got x plus 1 quantity squared over 36 plus y minus 6 quantity squared over 25. It all equals 1. Whew, okay. I got it in the standard form. The only other thing you might want to do is write this as 6 squared so you know that that's the major axes. Go right 6, left 6 off the center, and the minor is going to be 5 squared. Go up 5 and down 5 from the center. Are we supposed to graph this thing? Oh, we're just supposed to identify. Okay. So the center is just going to be negative 1, 6. Well, let's go try to find a center of negative 1, 6 up there. And their graph paper has been pretty crappy so far. But this first one already looks like the center is at, I'm going to use a different color because, okay, negative 1 up 1, 2, 3, 4, 5, 6. Well, that's good. This is negative 1 down 6. That's not going to do it. That's down below. And this is positive 1 up 6. Well, this is, okay, just by the process of elimination of the center, it's going to have to be A. But let's continue with this just for practice purpose. So under the x value is this 6, right? So that means I need to go horizontally 6 in both directions, starting from the center. So that means I go right 6, and they don't mark this very well. But if I go right 6 from negative 1, that puts me at 5. And if I go left 6 at negative 1, that puts me at, let's see, a negative 7. So that looks good. What are these other little points? These are foci points, which, like I said, we're not holding you to that. So I didn't ask any questions. I asked you to find the focus points or foci. Now, how far do you go up? Well, remember that was in green. That was in green over here. How do we know it's up and down? Well, because the y value is right above it, and y is vertical. How do you know the red was left and right? Well, because x's are left and right. So we know from the center we go up 5, down 5. From the center we go up 5 and down 5. From the center we go down 1, 2, 3, 4, 5. There we go. And from the center we go up 1, 2, 3, 4, 5. There we go. That is definitely the graph. And we started off with this general form, which was not very useful. We had to do a bunch of work to get it into standard form so we can take and pull all that great information out of that once it was in standard form. Let's go ahead and take a look at the very last problem now, number 11. They're asking us to please find the equation of the ellipse. Okay. The first thing I'd like to say is, well, there's my center, right? So that means that I'm going to start by writing opposite. I have a x value of the center is 1, so it's x minus 1 quantity squared. And the y value is 2 for the center, so it's y minus 2 quantity squared. We know the standard form is equal to 1. And now the next little bit of information, we got to calculate how far do we go here to get to the ellipse. Well, what scale is this? Okay, good. So we go right 1, 2, 3, 4, 5, 6. That's 6. So under the x value is 6 squared. And what's associated with vertical is the y. So I go look up and I go up 1, 2. Man, the scaling, the drawing of this graph is something else. Anyway, so 2 up, which means this must be 2 squared. Is it 1, 2? Yeah, it is. It is scaled like that. The scale is okay, but the drawing of those little boxes are supposed to be squares, and they're these elongated rectangles. It kind of bugs me, as you can tell. So there is the answer. That's fine. Did I put these in the computer? I don't think I did. Because, like I said, I like to put them in. No, it seems like I did. I can't even remember if I did or not. I think I did. What I'm guessing is that they're going to be okay with leaving that as 6 squared. If not, they're going to want you to do this. Wait, let's read the directions. It says, the equation of the ellipse is this. Simplify your answer. Type an answer using x's and y's as the variables. Okay, that doesn't tell me. But, they're probably going to want to say quantity x minus 1 squared, and then 6 squared is 36, plus y minus 2 quantity squared over 2 squared is 4, and that equals 1. Once again, as I said before, if you wrote this and they said it was wrong on the test and didn't give you any credit, I would write down, because you could always go back and look at your answers after you do a test. And if they do that, you just send me an email and say, hey, can you please look at this problem number, 15, and this is what happened, and I'll go in and make that adjustment, because both of them are fine, right? This is great because it helps us to see how to graph it, and this is just, you just squared them and made them slightly simpler, but I don't know. I'm fine with either way. Okay, that is it, and I hope you're having a great, great day, and we'll talk to you soon. Goodbye.